So I'm Stephanie Vasko. I'm a third-year graduate student in materials chemistry, and I'm also enrolled in the dual PhD program for nanotechnology. And today I'm going to be talking to you about the paradigm shift of nanotechnology, consequences of status quo lab attitudes. So the first thing I want to talk about are some results from the McGinn survey of nanotech researchers. So if we look at how many people are interested in ethical issues relating to nanotechnology, we have a fair amount who range from moderately to very. And when it comes to how important they believe that these ethical issues are considered, we again see a strong correlation in the moderately to very sector. However, when we look at the question, in your opinion, how does the importance of the ethical dimension of the nanotechnology field compare with the importance of the science dimension? The shift moves more toward that science is more important than ethics, but we have a 43% who think it's just as important. And so from this question, the most interesting question to me from McGinn's survey is a three-part case study. So he asks an initial question, which is, an experienced nanotech researcher, never involved in a lab accident, plans to carry out in the lab for the first time what she or he, and then gives three options. So the first is, realizes is a potentially hazardous procedure, and to do so without informing the workers who share his or her bench. And we see that most people find this to be completely unethical. In the second case study, it realizes that it's a potentially hazardous procedure, and to do so without fully searching the existing literature. So we see a bit more of a different trend here. We see that some people think it's completely unethical, some people think it's somewhat, some people are ethically neutral, and we get a large spike in ethics isn't relevant to this action. And in the third and final option that was given for this case study, it's that the scientist believes that it's a non-hazardous procedure and will do so without informing anyone involved. And again, you see a wide range from completely unethical to ethics is not relevant to this action. So the motivation behind creating a case study that discusses lab attitudes and how we look at nanotech in the lab is not about the future of nanotechnology, but more about the present, more about the graduate students who are currently working on nanotech, their PIs, the people who have to dispose of the waste, and everyone involved in the life cycle of the nanotech. So we'd like to get graduate students and undergrads to think about their lab habits, and we also want to think about how we deal with new types of classifications. So the technology we picked to focus on in this case study is quantum dots, because it's kind of the ubiquitous nanotechnology that you hear a lot about, from books written by Michael Crichton to G.I. Joe. It's in popular culture, so hopefully we at least think that the public is somewhat exposed to the idea of what a quantum dot is. So quantum dots show a lot of promise in varying industries like solar power, in vivo cancer imaging, and optoelectronic devices. But on the other hand, they're also made of toxic materials like cadmium, lead, selenium, and tellurium. So in the format of this case study, we look at a few common occurrences. How do you dispose of waste in the lab? What are the safety conditions? And how do safety inspections work? And the case study follows the decision tree format. And so our case study follows one tree, and it's the probably most strict of the trees. It looks at the worst of all possible cases. But for discussion purposes, you can choose to follow other decision trees with this case study. So we've got two characters in a lab who produce exotically doped quantum dots. We have Alex, who's a new student, and Ben, who's a fifth-year grad student and also the lab safety officer. So Alex wants to know, how do you label your waste in the lab? There's no space on a label for waste that's nanotech, and I'll show you an example of this in a minute. So do you go with the status quo of how the lab is labeling their waste, or do you inquire how one would actually label some nanotech waste? So here we have a hazardous waste label from the University of Washington. This is what you fill out whenever you want to dispose of something and remove it from the lab. And so you can see there are a lot of categories that you can label your waste as. Corrosive, non-hazardous, ignitable, toxic, but there's no space to label it as nanotech. So what about working conditions? Let's say that Ben has a very messy fume hood, and Alex and Ben share space, and Alex is really concerned about his safety vis-a-vis this fume hood. So what can Alex do? He can talk to Ben, he can talk to his advisor, or he can talk to the safety coordinator of the department. So in red is what happens in the actual case study. So just to follow this decision tree, everything that's outlined in red is what's written in the case study. If nothing happens, if Alex talks to Ben or his advisor, what should he do? if he considers whistleblowing the situation, what's the impact on his funding, and what's the future impact on his career? So I'm sure that some of you in the audience have seen fume hoods that look like this. So if you're Alex, and you're a first-year graduate student, how comfortable do you feel working in an atmosphere or an environment like this? So the other thing that is really interesting are things like EPA spot checks, which happen to labs fairly frequently just to make sure that everyone's in compliance. So in a spot check, Alex could voice his concern about the nanotech study or the nanotech situation or Ben's hood, or he can stay quiet and the EPA could cite the lab depending on their own findings. So if Alex chooses to discuss Ben's hood with the agent, the EPA will do things like investigate the background of the lab, investigate the lab's permits, look at the compliance history of the lab, and possibly involve other agencies such as OSHA. And so in that case, if OSHA and other agencies are involved, you also bring in RCRA, the Resource Conservation and Recovery Act, and so they're going to identify the pathways that the waste that you create takes, and they can either put a hold on your case and investigate more information on it, or start a full-blown investigation. So they'll take samples, they'll take photos from your lab, and they'll look at the pathway of the waste. So the way that legislation is currently written is that the generator of the waste is ultimately responsible for any incident involving the waste during its life cycle. And material safety data sheets don't distinguish nano properties from the bulk properties. So in an EPA, OSHA, RCRA investigation, in the final report, the students, the advisor, the department safety manager, the contracted waste disposal company, and all of agents from those organizations will be present. And so what can happen to you in this? Well, you can be fined, and they'll detail your infractions, and you can be closed until you comply. So one of the interesting things involves disposal of nanotech and labeling your waste. Currently, there's no test for landfill disposal of quantum dots, but California is doing a really interesting thing, which I think is important for the application of this case study, and it's that they've got a Department of Toxic Substance Control. And they find that nanotech is going to become the new plastic because it shows up in a lot of industrial applications. So they've started a partnership with the industrial sector to develop an ecology of manufacturing, stewardship approaches, and also they involve industry in developing analytical tests for these nanoparticles. So in this case study, there are a lot of areas for discussion. What is your perception of the events based on your gender, your expertise, or your motivation? What are your ethical responsibilities if you're the first-year grad student in the lab? Should you anticipate the dangers of the situation that you see around you rather than alert, or do you wait until it becomes an actual full-blown problem and then deal with it? And the last part is, what effect do gender roles have on the morals and views that you hold on the situation, and what is your perceived retaliation of whistleblowing in this case study? So the one other place that I want to look is at student resources. If you're this first-year graduate student, who can you talk to about the problems that you see? Well, you can talk to your safety liaison for the department. You can talk to your PI. You could talk to your graduate school advisor. But probably the most interesting place to go would be to talk to other students. So at UW, you have students who are in related organizations, such as the Nanotech Student Association and students in engineering and business, who have probably had experience with these types of events. And one thing I want to highlight is graduate student mentors. I think this is a really important idea, is to pair younger graduate students with older graduate students in order to help them get a feel for grad school and a feel for the resources that they would have available. The last issue I want to talk about are nanotech safety classes. So most universities, when they train students into lab and give them hazardous waste training, don't have specific nanotech safety classes. So who would pay for the development of this? Who would develop the curriculum? And would it have to just be for first-year graduate students? Or would it be for custodians in the life cycle, such as the janitors who empty the trash from the labs or the waste management companies who work on the processing? We'd like to outline some helpful teaching aids for this case study. So there's a review on quantum dots that's listed with the case study, 2 really interesting articles on ethics, and some articles on nanotech disposal from the Woodrow Wilson Institute Center for Scholars. And there's also, on the Woodrow Wilson website, a case study that discusses just industry waste of nanotechnology and how that's processed. So with that, I'd like to thank Marjorie and Deborah for giving me the opportunity to work on these case studies, Ethan for helping me figure out the issues involving decision trees, and my co-author, Billy Butler. Thank you.